This video is going to cover the properties of the unit circle. It's our last learning target on our unit of trigonometry, learning target 6. I can use and apply the properties of a unit circle. Here is a circle with a radius of 1. I want to do a little review and talk about the circumference formula of a circle. Circumference is always a big capital C, and it's equal to 2 times the radius. In this problem, since the radius is 1, my circumference is equal to 2 times pi times 1, which is just 2 pi. So a circle with a radius of 1 has a circumference of just 2 pi. What does that mean for our unit circle? Well, our unit circle also has a radius of 1. So this means if I travel all the way around my unit circle, I have traveled a circumference of 2 pi, which is the same as 360. If I were to travel only halfway around the circle, I would have traveled half of that 2 pi, which is just 1 pi. And that is our half our circumference at 180. What I'm creating here are called radians. And radians are another way to split up the circle using the pieces of the circumference. If half of the circle is pi, then what's half of pi? Well, that'd be pi divided by 2, which is our 90-degree radian. What's half of a half? That would be a fourth, which is our 45-degree radian. Starting counting by fourths, I can come up with a lot of new ones. 1/4, 2/4, I have it, 3/4, 3 pi over 4 for 135. 4/4, I have it, 5/4, 5 pi over 4 for 225. I'm at 5/4. 6/4. 6 over 4 I can reduce down to 3 over 2. So 3 pi over 2 for 270. Again, I'm at 6/4, 7/4. 7 pi over 4 for 315. And 8/4 takes me back around to 2 pi. To get the other measurements, let's cut our pi into thirds. So here is 1 pi. I'm going to cut my 1 pi into thirds. That means I'm cutting it at the 60 degrees. So pi over 3 is our 60 degrees. 2 pi over 3 for 120. 3/3 is actually already there. So now I go down to 4/3, 4 pi over 3. And that's our radians at 240. Cut my pi into another third, and now instead of 4/3, I'm at 5/3. That's my radians at 300. Now I can cut this 1/3 of the circle in half, and a half of a third is a sixth. So pi over 6 is our 30-degree radian. I'm going to start counting by 6. So 1/6, 2/6, have it. 3/6, 4/6, have it. 5/6. This is my radian at 150. I'm at 5/6. 6/6, I have it. 7/6. This is my radians at 210. I was at 7/6. 8/6, I already have it at 240. 9/6, I already have it at 270. 10/6, I already have it at 300. So I'm at 11/6 of the circle. And that is my radians at 330. These are the radians of the unit circle. You use them when trying to find the values of trig ratios, and they're easy to be created by dividing up the circle into fourths, thirds, and sixths. There's an easy way to convert degrees that are not on the unit circle to radians or radians into degrees. Let's do a couple quick examples. This is the formula we use. We put an x in the part that we want to create, and we put the given information in the spot that it deserves. If we want to convert 115 degrees into radians, then I need to plug it into the degrees spot of this formula. 115 over x. I want to create radians, so I put an x in the radian spot. I now go ahead and multiply, and I end up with 180x is equal to 115 pi. I divide both sides by 180, and now I have my x. If I can reduce, I should reduce. This goes down to 23 pi over 36. Let's try this one more time, but go the other direction. Create degrees out of a radian. So again, 180 divided by pi is equal to, I want to get degrees, so put the x in the degree spot, and put our radians on the bottom, 3 pi over 10. So now when I multiply, I end up with pi x, and this equals 180 times 3 divided by 10, which is 54 pi. We divide both sides by pi, and my x is equal to 54 degrees. Let's think about the unit circle and remind ourselves what these coordinates are. Each of these coordinates are an x and a y, and they are found by traveling x and then traveling y. This forms into a triangle. What this means is that the triangle's hypotenuse is the radius of the circle, which is 1. So something that has to work for this triangle is the Pythagorean theorem. This means that x squared plus y squared equals 1. This is the equation of the unit circle. So let's reconsider this equation. Since we know from our previous lesson that all x's are answers to cosine and all y's are answers to sine, we can substitute the x and the y with sine and cosine into the equation that makes the unit circle. I end up with something that says cosine squared plus sine squared equals 1. We like to actually reorganize this and shape it up a little bit so that it says sine squared theta plus cosine squared theta equals 1. This is called the Pythagorean identity. We can use the unit circle equation to check if a point is on the circle or not. All we have to do is substitute the x and y values to find out if they work in the unit circle's equation. So remember, the equation is x squared plus y squared equals 1. Let's substitute. 5 divided by 13 squared plus 12 divided by 13 squared, will it equal 1? Well, 5 is 25 over 169, and 12 squared is 144 over 69. This comes out to equal exactly 1, because 169 divided by 169 equals 1, and that's what 25 plus 144 equals. So this is good. This point is actually on the unit circle. Let's try it for another point. Is the coordinate 2, 1 on the unit circle? Plug the 2 into the x spot, 2 squared. Plug a 1 into the y spot, 1 squared. Will it equal 1? 2 squared is 4, 1 squared is still 1. Will it equal 1? No. 5 does not equal 1, so this point is not on the unit circle. Suppose you know that cosine theta equals negative square root 2 over 2, and that this theta is in between 0 and 360. What are the values for sine? What this means is that on the unit circle, we're at a x value of negative square root 2 over 2. That could be actually in 2 spots. It could be here at 135, or it could be here at 225. At these two locations, the y value is positive square root 2 over 2, or at negative square root 2 over 2. So what are the possible values for sine of theta at these 2 points? Positive or negative square root 2 over 2. Don't forget to click forward and answer the questions, and make sure you hit the submit button so I have record of you watching the video. If you have questions, please make sure that you text me or write them down and share them when we get back in the class.